Good morning, everyone. This is Sutrishna. So today again we will practice some questions of logarithm, and I hope I am audible and visible. Uh, so without further delay, let's start. Okay. Today we will be doing some sums based on the property of logarithm. Sorry. So I think all of you know the property of logarithm. Am I audible? I think yes. Hello. Yeah. Okay. So let's start without any further delay. And last class, maybe there was some technical problem. For that, audio was missing from that clip. So I have decided that I will re-record it and upload it. Okay. Or I will help you somewhere. Okay. So without any further delay, let's start. So I think all of you know the property of log, right? So what is the property of log? If I'm writing log a bis b equals to c, then there is some properties of log. I think all of you know that, but here I'm going to discuss only a few properties because, as I said, I'm not taking this class uh, from the base. It is completely, you can take it revisions as a revision session. So that's why only few properties we will be discussing. Okay. So this is this base, then this B and A, they both should be greater than 0. This base and this also, they both should be greater than 0. And one more thing is there we have to take care of, that is this A must be not equals to 1. Okay. Base must not be equal to 1. Okay, you can take in decimal 0 0.5, 0 0.4, everything is allowed, but it cannot be 1 and it has to be greater than 0. Okay, positive. Now I would like to write some questions, and in these questions you must focus because there are so small things that you have to take care of. So the question is, which of the following pairs of expression, which of the following pairs of expression are defined for the same set of values, are defined for the same set of values. Okay, so that is the question. So here I will be writing some pairs of function or expression. Okay, and we have to find out that for which it is defined for same set of values, or uh, which uh, which are the pairs who has same domain. Okay, so let us find out. The first pair I am writing is f1x is equals to 2 log 10 base x, and f2x equals to log 10 base x square. Okay, so as I said that in log, this base should be greater than 0. Base is already greater than 0. It is 10. Here is base, here the base is 10, here also. But what about this x, right? Then we have to take care of this x also. This also should be greater than 0. Now, see one thing here. For the first function, it is written as this. But for the second function, f2x, so this is x square, right? This x is in power. So what I can do, I can write this power in front of log, right? Like I can write 2 log 10 base x. Okay. So now this two function looks like the same function. But what about the domain where it is defined? It is defined like for x to be greater than 0. For x to be greater than 0, it has to belong from R positive, right? It has to be R, it has to belong from R positive, means positive real number. Suppose this is your real number line and here is 0. So after 0, from here to infinity, for every positive integer, in every positive decimal number, means I can say for every positive real number this will be defined, right? But what about this? Here we have x square, right? Here what we have x square. So the thing, x square. So if I take -1 also, its square is positive, right? It is +1. So here in this case, we can take any number other than 0. So it is defined for every real number other than 0. Okay. So are these two domains same? I don't think so, because here in this case we have to take only positive real numbers. But for this, for F2, we don't have to think like that. We can take any real number other than 0. Because if I take 0, then it will be 0 here. But if I take any negative integer also, if I take any negative decimal number also, it will come as positive, right? So that's why they have two different domains. Okay, so let us move to our next pair. Huh. So what is our next pair? That is f1x, sorry, huh. f1x is equals to log x base x square log x base x square, and if 2x that is equals to 2. Okay, that is equals to 2. Now what we have to do, if 1x is log x base is x square, and if 2x is equals to 2. So here I can also write like if 1x equals to, this 2 will come here. Now it is log x base x, which is equals to 1. So I will get simply 2 here. But here f2 is also 2. But the thing is f2x, this is only a constant number, right? So it is everywhere defined for all real number. This f2 is defined for all real number. F2 is defined for all real number. But what is the case with f1 where it is defined? F1 where it is defined. So for that we have to take care of the domain of it, which is, we all know that this is also x, base is also x, and here. So what we will do, we have to take care that this a and b means base is also x, okay, and this is also x. So what we will do, x will be greater than 0. This is a necessary condition, and then x is not equals to, x cannot be equals to 1 also, right? As we learned the condition in previous slide. So as per that, x will be greater than 0 and not equals to 0 also. So I'm going to write third pair now. Okay, so third pair is a little bit lengthy. So defined for all real number I wrote, right? Okay. So for third pair, right here, f1x that is equals to log 10 base. This will be x minus 2 plus log 10 base x minus 3. Okay. So x minus 2, x minus 3. Base is, you can see, 10, and here also 10. So both are greater than 0. So to get this function defined, we have to think about x minus 2 and x minus 3. This should be also greater than 0, right? So now let us think, if I take x greater than 3, greater than 3. Okay, if I take x greater than 3, then you can understand that what are the numbers greater than 3? Suppose 4, 5, 6, integers, or you can take 3.5, 3.7, something like this also. But you can notice that when you will put these values in the place of x minus 2 also, you will get greater than 0, right? Like 4 minus 2, 5 minus 2, these are all greater than 0. And here also 4 minus 3, 5 minus 3, these are also greater than 0. 3.5 minus 2, if you do, you will get 1.5, and that is also greater than 0. That means without writing two conditions separately, we can write only one condition, that is x minus 3, sorry, x minus 3 greater than 0, or x greater than 3, right? Means if I choose x which is greater than 3, that means it is already greater than 2, right? If I am choosing x which is greater than 3, so that means it is already we are confirmed that means it will be greater than 2. So that's why we can write a single condition, that is x is greater than 3. Okay, so now let me erase these things. Okay. Okay, so that was our F1. Hmm. That was our F1. So now what about F2? What about F2? F2 I'm writing here. Huh. And F2 is log base is same 10. It will be x minus 2 into x minus 3. See, there is very minute difference between these two, but their domain will be different. They will be defined for different x. Okay. So what is that? Where it is defined? Okay, we will find out. Don't worry, we will find out that. So see here, to get this F2 defined, we need to have this, right? As per our previous slide, as per the condition of log, this should be greater than 0. That is what I am writing. This is greater than 0. So, what it takes to be greater than 0? Suppose if I am choosing x, so you know to be greater than 0 means it is a product. So, for a product to be greater than 0, what are the condition? Either both is negative, okay, either both are negative, or what? Both are positive. So, two conditions we can find. One is both negative, another is both positive. So, if I consider the first condition, which is both negative, so what I'm going to write here, suppose if I take less than x less than 2, means if I choose 1, if I choose minus 1, if I choose minus 5, so what I will get, suppose I'm choosing minus 1, so minus 1 minus 2, okay, and here minus 1 minus 3. So see, this is minus 3 and this will be minus 4. So if I do the product, I will get plus 12. Okay. So that means whenever you will choose x which is less than 2, you will get a positive number here. Okay. So for all x less than 2, we will get positive number. So here we will get both negative. We will get here also both negative. If I choose x less than 2, then both of this will be negative, and negative into negative we will get positive number. But what if I want to get the product of positive numbers? So then I have to anyhow choose x greater than 3, right? If I want to get the product of two positive number here, so I have to choose x greater than 3. Okay, I should write it. Hmm. Or x greater than 3. Why I wrote or? Because both both of these are feasible, right? If I take x greater than 2, then also it is feasible. If I take x greater than 3, then also it is feasible. So if I take like x equals to 4, 4 minus 3, it is greater than means it is equals to 1, so it is greater than 0. And if I take 5 which is greater than 3, so I will get here also greater than 0. So I can choose one of this condition. Either I can choose x minus 2 or I can choose x greater than 3. Okay, so in number line how I can show it? In number line, uh, suppose this is my number line and this is 0, so this is 2 and this is 3. So either I can choose greater than 3 means from here to infinity, or I can choose less than 2. Less than 2 is this. Okay, means minus infinity to 2. Okay, so that is the thing. For this question, it is this much only. So if you like to do one more question, okay, let us do. Hmm. Okay, let's do it fast. Log question number 3 I'm writing, or 2 it will be, no? Question number 2. Log, this is very easy question actually. 2 base x plus log 4 base x plus log 16 base x plus log 32 x plus plus which is equals to 6. Okay, that is the question. Okay, so that is the question. Then find the value of x. We have to find x. Okay, find x. So what I can do is, as you can see, these are all powers of 2. This is also power of 2. This is also power of 2. These are all powers of 2. So what I can do is log 2 base x plus log 2 to the power 2 base 2 to the power 2 base x plus log 2 to the power 4. 16 is 2 to the power 4 and 32 is 2 to the power 5. Okay. So now what is the next step I can take? As per log has another formula. I will not say formula. This is a property. So what is the property? Like if I have something in the power of base, if I have something in the power of base, so I can write it, means this power here, no power is there, so I can write 1. Okay, so I can write it like the power will come to the front. Okay, so 1 into log 2 base x. Here it will be 1 by 2 into log 2 base x, means this power, it will come as a reciprocal of it to the front of log. Okay, it will come to the front as a reciprocal, the power. Okay, so that is the property. 2 base x plus 1 by 5 plus log 2 base x plus dot 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 equals to 6. So here what I can see, 1 plus 1 by 2 plus 1 by 4 plus 1 by 5, 5 like that it is going on. But okay, fine. I thought 1 by 3 will also come, but here 8 is not there, so that's why. And here outside it will be log 2 base x, okay, equals to 6. Now what I can do, okay, so what I can do is, this is, you have learned AP, GP, HP, right? So the difference of this, I can take as 1 by, means 5, 6, it will continue like that, okay? So 1 minus 1 by 2, okay, that is the sum of the series 2 to the power x equals to 6, okay? So log 2x, and here it will come as half, okay? So this half will, I can cancel it with this, means 6 into half, so this will be 3, okay? So now I'm getting, the thing is log 2 for x equals to 3. So what is the value of x then? X is 2 to the power 3, right? X is 2 to the power 3, and that is equals to 8, okay? So that is how we are supposed to solve it. That is how we are supposed to solve it, okay? So let keep this session this much. Meet you again. Thank you everyone. Let me end the session now. And I'm thinking to use a new writing pad. So I think this is not comfortable. What is your opinion? You can let me know here. And if you know any other software which works better, please let me know. Thank you.